Newton's first law of motion states that an object in motion tends to stay in motion. This is readily apparent in the following skiing videos. When the skiers fall, they continue to stay in motion simply due to inertia. Outside forces, such as frictional forces of the mountain slopes, are the major causative agents involved in stopping the perpetual motion. Because the mountain is slippery, it exerts low frictional forces, causing the skiers to remain in motion for extended periods of time, such as this unfortunate skier shown here.
Newton's second law of motion states that an object's net force is equal to the mass of the object multiplied the acceleration of that object. Therefore, the acceleration of an object is directly impacted by the net force of the object and is inversely impacted by the mass of that object.
A good example of this concept is the flight of a golf ball. The net force exerted on the ball by the club causes the ball to accelerate forward quickly over a great distance. This occurs because the ball is a small mass and the club exerts a strong force. Golfers with a higher skill level are able to exert more force on the ball, making it travel farther.
Newton's third law of motion states that for every action there is an equal and opposite reaction. An example of this law of motion is a basketball rolling on a basketball court floor. The basketball exerts a force upon the basketball floor, and in return, the floor exerts an equal and opposite force on the basketball, causing the ball to bounce back upward because the ball is a much lower mass than the floor.
The impulse momentum theorem states that an object will experience a change in velocity which results in a change in momentum when an object experiences a collision that generates a force on its mass over a given period of time. The impulse is the force multiplied by the time, and the mass multiplied by the change in velocity is known as a change in momentum. The impulse of an object is always equal to change in momentum. A simple example of this is a baseball bat hitting a baseball. A change in momentum to the baseball will occur when the baseball is struck with a bat. If the force and the time are increased by using a follow-through, the ball will experience a greater change in momentum, causing it to travel further and result in these home runs. Centripetal force equals mass times the velocity squared divided by the radius of the circle. Any motion traveling in a circular path will be accelerated motion. In order to keep this motion traveling in a circular direction, a force directed toward the center is required. Traveling in smaller circles requires a greater amount of force exerted toward the center. This type of centripetal force is used by horses' hooves during barrel racing. The hooves of the horses need to be bent toward the center to keep the horses traveling in a sharp circular direction. These horses need to exert an extreme amount of force in order to complete the turns and decrease the total time during the race.